The pattern 1, 8, 27, 64, 125, so on, is a cubic pattern named because the first number in the pattern, 1, is equal to 1 times 1 times 1, or 1 cubed. The second number, 8, is equal to 2 times 2 times 2, or 2 cubed, and so on. We want to use this pattern to complete parts A through D below. The first thing that I want you to understand before we even get started here is that 1 is going to be equal to 1 times 1 times 1, which is 1 cubed, as we've already stated. The next number, 8, is 2 times 2 times 2, which is equal to 2 cubed. The next number is 27, which will be equal to 3 times 3 times 3, or 3 cubed. And then there will be 64, which is equal to 4 cubed. And then 125 will be equal to 5 cubed. And we want to continue this pattern so that we can answer the questions that are given to us. So the first part of the question states, what is the least 4-digit number greater than 1,000 in this pattern? Well, since we're actually taking the counting numbers, the natural numbers 1, 2, 3, 4, 5, and so on, and cubing them, it makes sense that instead of trying to figure out what the numbers are as far as 1, 8, 27, 64, and 125 goes, we should actually start with 6 cubed and determine what that is equal to. And that'll be equal to 216. Then we want to do 7 cubed, which will be equal to 343. Then we will find 8 cubed, which will be equal to 512. Then we'll find 9 cubed, and so on. Now, one of the things that I'm going to show you is we have found the pattern from 1 cubed through 10 cubed. And if we look back at the problem, we'll see that we're looking for the smallest 4-digit number that's greater than 1,000 in this pattern. We already know that 10 cubed is equal to 1,000, so we could have started right here at this number and then figured, okay, since we are taking the counting numbers, i.e. the natural numbers, and we're cubing them, what would be the next natural number that I would cube in this sequence? And that would be 11. And so then we would cube that, and then we're going to get 11 cubed is going to be equal to 1,331. And this is going to be the answer for part A, 1,331. So now we'll go on and we will do part B. And part B simply states what is the greatest 3-digit number in this pattern. But since we've already gone ahead and done that, we know that the greatest 3-digit number in this pattern is going to be 729. The next part of the question, C, what is the greatest number in this pattern that is less than 10 to the 4th? Well, for this one, what we're going to do is we're going to change it up just a little bit, and we're going to use some reasoning behind this. First off, what is 10 to the 4th equal to? Well, we'll go ahead and we will calculate 10 to the 4th, and we will end up with 10,000, correct? Because 10 to the 4th is going to have 4 zeros in it. So 10 to the 4th is equal to 10,000. And now what I'm going to do is take the cube root of this, because what I'm looking for is a number cubed that's going to be just less than 10,000 when I cube it out. So if we take 10,000 and we go ahead and we find the cube root, that will give us 21.5443, and it continues. All right, this is not going to be a rational number. Now, how can I determine what is going to be the number that I'm looking for? Well, if the cube root of 10,000 is equal to 21.5443, that means that 21 cubed which is going to be the number just below 21.5, the whole number, is going to be the number that I'm looking for. So when I cube 21, I end up with 9,261. Now, just so that we understand what's happening, let's go ahead and consider what happens when I take the number 22 and I cube it. 22 cubed is going to give me 10,648. Therefore, we know that 21 cubed is going to be the answer that we're looking for, and this is the number that we are going to consider, 9,261. All right, and part D says, if this pattern was produced in a normal spreadsheet, what is the number in cell A14? Well, understanding that when we look at a normal spreadsheet, for example, this is Excel, and we would note that this is A1, this is A2, this is cell A3, this would be cell A14. If we were to do the pattern, this would be 1 cubed, 2 cubed, 3 cubed, 4 cubed, and I can show you that by simply typing in the fact that we have equals 1 cubed, and then we will type in the formula equals 2 cubed, and you'll note that we have 1 here, and I cube it, I get 1 over here. We have 2 here, and I cube it, I get 8 here. 3 is right here, so we'll cube that, equals 3 cubed. And instead of typing in all of this, I'm simply going to say, okay, well, this is going to be the natural number 14 cubed, and when I cube that, I get 2,744. And that's all I need to worry about, is looking at this A14 and taking the number component, cubing it, and that will be equal to 2,744. And I'll go ahead and write that number right here to be consistent.